Hello, let's continue our Sudoku adventure with V is for Vista by Randall. So this is the final puzzle of our Renban theme week. I hope you enjoyed it, and I hope it gave you a little bit more practice with Renbans. So yeah, let's go over the rules to this final puzzle. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have Renbans in the grid. These are these purple lines. So digits on the line form a set of non-repeating consecutive digits in any order. So let's just take a short one, for example. This has 3 cells on it, so we need 3 consecutive digits, like 2, 3, 4. So if this had 2, 3, 4 on it, it could be in any order, but this would be a valid Renban, because when we take these digits as a set, they do form a consecutive run of digits, 2, 3, 4. What we can't do is like put a 5 here because 2, 3, 5 is not a consecutive run. All right, in addition to that, we do have these black dots in the grid. Digits separated by a black dot have a 1 to 2 ratio, meaning one is exactly double the other. So if this was a 2, this could be 4, because 4 is double 2, or this could be a 1, because 2 is double 1. So the order doesn't matter. What matters is that one of them is exactly double the other. Now, not all our dots are necessarily given, meaning if we had 2, 4 here, there could have been a black dot, and there's not, and that's perfectly fine. You're still allowed to put 2, 4 like that. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, how do we want to get started here? We do have a 1, 2, 3, 4 length Renban here and a 4 length down here. So this black dot sees the entirety of the 4 length Renban. I think that's very important. Which means that the set of digits on the Renban plus the black dot is all 6 digits, right? Because both the black dot sees these 3 through the box and this through the column, and there's no repeats on the Renban. So whatever goes on the black dot cannot go on the Renban. So the 2 digits across the black dot plus the Renban is 1 through 6. Now we know that a 4-cell Renban can only be missing extreme digits. We can be missing 1, 6, making it 2 through 5, or we could be missing 1 and 2, or we could be missing 5 and 6. And those missing digits go in here. So which set of missing digits of what I just listed can go on a black dot? And the answer is only the 1 and the 2. So this is a 1-2 pair, and this is 3, 4, 5, 6. That's a neat opening. Now this digit here goes here as the same digit, because this needs to go in the box somewhere. So you know what? Why don't we make that green? It's our green 3, 4, 5, 6. Okay. Now these 2 cells plus these also form a 1 through 6. So these are what's missing from this Renban. They can't be 1, 2. In fact, they're from 3, 4, 5, 6. Can't put a 5 on a black dot, but let's not worry about that right now. So we're not allowed to be missing 3s and 4s. That's kind of the point. And so we can only be missing the 5, 6 here. If we miss 3 and 4, we don't actually get to do a consecutive run. We can only be missing the extremes, 1, 2, 1, 6, or 5, 6. And since 5 can't go on a black dot because you can't have it to 2.5 and you can't double it to 10, we end up with 6 and 5 like this. 6 has to have to 3. This is not 5 or 6, meaning that's not 5 or 6. And in fact, green goes down here somewhere. It could be the 3, but then if it's not, it's this 4. 3 can't go up here. Okay. So this is the other 3, 4. This is the purple 3, 4. In fact, it can't be 3 because it's on the Renban, so we don't even need to make it purple. This is the 4, this is the 3, this is the 3. Get rid of green as well. We get a 3 in the corner. Deep, deep, doing. That's not a 3. 1, 2, 5, 6 here. So we know that this is 1, 2 pair because we needed this to be 1, 2, 3, 4 with the 5, 6 here. This 4 does end up here by geometry. That's not a 4. The 4 is in one of these 2. All right, we're doing well. So what's our next step here? I'm kind of interested in this. These are consecutive. So here, what do we need? 1, 2, 5, 6. This is also 1, 2, 5, 6. I don't know if that's helpful. 1 would put a 2. Well, we can't put a 1 or a 2 here. So this can't be a 1 because it would force a 2 here. 2 would force a 3 here. Seems okay. 5 could go with 4 or 6, and the 6 would go with the 5. Oh, so this can't be 6 because it can't go with the 5. 1 would put 2, 3 here. In fact, it would be a 2 here with a 3 here. The 2 would make that a 1. So 2 would have to go with 4. I don't know if I want to go case check 1, 2, 5, 6 on this right now. Is it this black dot? So there's no 3 on it. Right, that's important. There's no 3 on the black dot, so it's not 3, 6. So it's either 1, 2 or 2, 4, and it definitely has a 2 on it. Because 1, 2 or 2, 4 always involves a 2, meaning that this is our 1, this is our 2, and that comes back around telling us this is a 2, 4 pair, meaning this isn't 4, placing the 4. And then this 5, 6 ends up here. This is 5 or 6. Then down here we need a 1, 3, 5, 6. What do I do with that? So we can't put a 5 on a black dot. 3 or 6 would be with another 3, 6. Can't be with a 3, so it's not 6. 3 would go with 6. 1 would go with 2. Both seem possible. Ah, no, it's not. If this was a 1, I think 5's too far away. So that's another thing. But what I was going to say, if this is a 1, then we have to have a 2 somewhere on the Renban, but then this also has to be a 2, and that doesn't work because this cell sees the entire Renban. So whatever this is not on the Renban. So if it's 2, we can't put a 2 on the Renban, meaning this could be 1, and that breaks things. So this has to be 3, 6. That's our 5. That's a 4 to fill the gap on our Renban. That's 2 and 4. That's 6. That's 5. All right, let's clean this up a bit. These can't be 6. These can't be 5. This is the only place for 6 in the column. This can't be 3, 5. All right, 4 with 1 is too far away. We can do 4, 3, 2, but we can't get down to 1. So that's our 6. That's our 1. To bridge the gap, we need a 5. That's a 2 with a 3. That's 1 and 2. That's 1. Finish this row with a 2. Down here, we need 1, 3, and 5. This can't be 3, 5. So that's our 1. And then this 3 tells us that's 5 and 3. Column finishes with a 1. These two are 4, 6. We know the order, 6 and 4. Down here, we need 2, 5, 5 and 2, and we're done. All right, neat puzzle, Randall. I really like the interaction. We had quite a few cells that saw the entire Renban. So these two saw this whole Renban. These two saw this whole Renban, and this cell saw these 3. All very useful. This cell, I suppose, saw this Renban. I don't know if I didn't use that, but there's a lot of interesting geometry here. Cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.